Cool. Well, let's get going on the road here. So today is financial maths. And so I thought I would just show you where financial maths sits in the exam family. So it is in paper 1, and it's approximately 10% of paper 1, give or take. And so finance, growth, and decay. And when we think about financial maths, we think about really two important formulas. The one formula looks like that. And I want to know, what is that the formula for? Tell me in the chat. What is that formula for? Who knows? It's simple interest. Exactly. Simple interest. And its older cousin. This is the compound interest formula. So these are two really important formulas. Generally, when we deal with growth, they're written like this. But when we deal with something called depreciation or the loss of value, they are written a little bit differently. They are written like that and like, oh wait, like that. So I just want to check, what is the name for depreciation when it's done like this? Who knows the word for that? What sort of depreciation is that? Okay. This is called straight line depreciation. Put D. And what about this one over here? So straight line depreciation. What's the second one called? It's called reducing or diminishing balance. Yeah. And so it's almost like the cousin of compound interest, because we notice that the compound interest formulas have these powers of n. Okay, so those are important formulas. So that's the basics. Then the other important thing for the section is that you need to know about compounding intervals. So if I gave you, in the section, if I say to you something like 12% interest per annum, you need to be able to translate that into a decimal. So put it in the chat. What is 12% per annum written as a decimal? Yeah, so it's 0.12. Okay, awesome. Now, if I asked you, I want you to, instead of, this is your nominal rate or your quoted interest rate, 12% per annum, I want to know, what is this if it's compounded, not per annum, but per quarter? So what is that interest rate if it was compounded per quarter? How would I work that out? So I'll just say here, quarterly. How would I change that to a quarterly interest rate? Or what would that be? So at the moment, the interest rate is per annum or per year. If I wanted it to be a quarterly, I would take the 0.12 and I would divide it by 4, and I would get 0.03, which is the same as 3% or 3% per quarter. So in this section, we have to be comfortable going from interest rates in one time period and changing them to an interest rate for another time period. And we also have to be comfortable going from taking something like, and let me just do this now. If I ask you, if I give you 5 years and I want you to write that in terms of quarters, tell me in the chat what 5 years is in terms of quarters. So what is 5 years if we write it in terms of quarters? So it's just going to be 5 times 4, which is 20. So this idea is going to come up again and again throughout financial maths. This idea of, can you change the interest rate period to a certain shorter interval? And then how does that affect the overall number of those intervals? Okay. Then there's another formula that we need to know about. And it can be written in 2 different ways, but it's called the effective interest rate. And it is written 1 plus give me a thumbs up if you've seen this formula before. Just want to see if you've seen it before. And it talks about, it's like a conversion between the effective interest rate and the nominal interest rate. So I nom, and then this one is I effective. Okay, so let's take the example we did above, or let's try and just show you how this is worked out. If you are given this information, so if you are given the information that the interest rate is 12% per annum, and that's the nominal interest rate, but they say to you, you are going to compound that interest rate quarterly. Okay, so that's what's going to happen. Now, because you are compounding it quarterly, it's going to end up having more interest than if you compounded it yearly. So just think about that for a second. If you agree with me, give me a thumbs up. If you disagree, give a thumbs down. If you shorten the compounding interval, you end up getting more value. The interest rate ends up being effectively higher. Does that make sense to you? Okay. So let's see how this would play out. If I said to you, calculate the effective interest rate, if you're given a nominal interest rate of 12% per annum, but you have to compound it quarterly. And so you're going to use this formula to help you convert. What you do is you simply put 0.12, which is what the nominal rate that they gave you, and you divide it by 4. And then what's going to happen is you're going to find what M is. Now, what is M going to be? It's also just going to be 4. And then you're going to take away 1. Now, I want you guys to type that into your calculators and see what you get. What is the value that you get, the decimal value that you get? I'm going to put it into my calculator now myself. 1 plus fraction button, 0.12 over 4, close fraction to the power of 4 minus 1. And I get 0.125508881. Now, normally what we do is we round up to 2 decimal places, but we write it as a percentage. Now, in this case, 0.12 or 12% per annum, if we converted this back, this would be 12.55% effective interest rate per annum. And what you notice is that the effective rate is higher than the nominal rate because you shortened the interval that it was compounding over. You shortened it to quarters. Now, this was just we're going to do questions like this in the next two lessons, but I just wanted to give you a quick show of how we relate the nominal interest rate. We break it down into a smaller chunks of quarters, and how that means that the effective rate ends up being higher. And then I kind of just went for it. So thumbs up if you kind of followed what I did. Thumbs down if you're feeling a bit unsure. Just want a quick check-in with the people of the land. Okay, so as we look back on my quick little revision session, we know that we need to be able to use these formulas above: compound growth, simple growth, straight line depreciation, reducing balance. We then need to know how to work with different intervals and interest rates. And then we also have this nominal and effective type of question. The only other type of question really, which we won't probably touch on too much today, or if we do very basically, is what's called the timeline question. And a timeline question is just when something is growing generally over time, and there's a change in the interest rate or the length of time that's involved. And normally you start up with something here, and it goes through a journey, and different things happen to it, and they ask you, what does it end up with? All right, and so these are the main type of questions that you get in this topic. Okay, but let's start at the very beginning, and let's just do some basics just to get our brains moving. So I will give you the formulas above. In fact, I'll write them in for you, and then you can just work them out for me. So question number one, the simple interest formula is that I want to know how much will you owe after 7 years if you borrow that much at that interest rate. And we're going to do a series of short little questions now, just to check if you understand the main ideas, and then we'll build up over time. Pop those answers in the chat. So the key with this question is you need to know what you're trying to find, and what you're trying to find is the A value. But that means subbing in for this one, and this one. And you should get that should be 7. You should get 489. Okay, so that's a simple interest question, just applying the A, the P, the I, and the N, and I'm going to move straight along. Okay, let's change. Well, let's have the same question sort of, except it's now the compound interest formula. And I want you to find the answer for that one. The only difference was, at this time, it was compound interest. And so your answer should be 548.41. What do you notice? So everything about these two questions was the same, except for one thing. What do you notice about compound interest and simple interest? Does anything stand out to you? Pop your hand up, or if you look at the calculation that you did. Yeah, Google it. What did you notice? Can you unmute? I think you need to unmute yourself, Guguletu. I think you may have, there's a little buzzer at the bottom there and it says unmute. I'm asking you to unmute, I think. Here we go. What do you notice? Okay, I think we may have lost. So I'm looking at the chat, and basically and I think this is what Guguletu was going to say, is that you notice that the compound interest gets to a higher number. So the simple interest was 489, the compound was 548, and with compound interest, it's grown faster. And generally speaking, if you visualize how things grow over time, with simple interest, it would start and look something like that, and it would go up more regularly. And compound interest, so simple interest looks like a straight line graph, whereas compound interest looks like an exponential graph. So if you start there with P or P value, and this over here is time, then what's going to happen is that the compound interest is going to grow quicker because of the exponential bit here. This power of n makes a big difference over time. And sometimes you see exam questions where they ask you to compare and identify. So I just want to make sure you understand that compound interest is related to the exponential function. Simple interest is related to the straight line function. Okay, but I think, yeah, let's move on. Let's move on. Okay, 6.1.1. Let's do this question. And there's a slight difference, and all I'm going to do is highlight that difference for you. The rest, I want you to work out. And this is 10% per annum. If they haven't mentioned it, 10% per annum, but they want you to compound it quarterly. See if you can answer that question. Ask yourself what's different about this question and what parts will it affect? So the key step is to realize that your interest rate needs to be divided up into quarters, and then your time period needs to be multiplied into, if you chop something up into smaller pieces, there's more of them. And so when you pop the answer in, you should be getting something like that, 3,074.83. Okay. And the first thing that you see here is you're now breaking things down into compounding intervals, and that changes how the calculation is done, but it's only slightly changed. Give me a thumbs up if you're feeling good. I don't want to go too fast, but I get the impression we're doing okay. But if I need to slow down, just thumb down and I'll know. Okay, let's keep the show rolling. So you were given that question over there. So 25,000 is invested into a savings account, and they give you two different, the value of the investment after 5 years, and there's two different possibilities for the interest rates. I want you to work out both. And while you're working it out, if you're feeling confused, this is a great time to ask a question, because I'm here, I'm willing to have a chat with you. But at the same time, if you're feeling confident, go ahead and do it. just check that but please do make use of the chat functionality or the hand raising. Yeah. So the main ideas are just, again, knowing how to find what I is, how to find what N is. And then because it's compound growth, we need to use that formula over there. So a lot of people are giving A at 43222.89. That's looking awesome. See if you can get me the answer to B as well. All right. Let's look at the answers here. So that should be your answers, 43,222.89. And then for the other one, 42,703.61. So watch out for the semi-annually, because semi-annually means twice a year. So your interest rate is going to be divided by 2. Basically, semi-annually just means 6 months, every 6 months. And so there's 2 6-month periods in every year. So we go 5 times 2, which gives us 10. Okay. Okay, so this feels like we've got this. Now, the next type of question is, instead of giving you the P, I, and N, the question can give you a different combination. So they might give you the I and the N and the A, and you have to work out the P value. Okay, so that's the type of question that I'm going to go to now. And yeah, let's go on to that now. So let's go to this one. So in this question, it says that the population goes from 12,000 to 214,000 in 10 years. At what annual rate, compound rate, what annual compound rate does the population grow? So my hint to you is they're no longer asking for A or P, they're asking for something different. For I, can you adjust your working to find what that is? Okay, so Bonga has said, don't we substitute for A, P, and N in the equation? We do. So Bonga, what we do is we say this is 214,000 and this is 12,000. The I we don't know, and the N, because the annual compound rate is just that, it's just going to be 10. But now we've got a bit of a problem. We're a bit stuck. I was wondering if anybody could help me. How do I get this I by itself? Because it feels like someone locked the I away and threw away the key. And so now I need you to help me find how to unlock this key. What if only I could undo raising something to the power of 10? Yeah, David, let's go to you.
Okay, sir, I have an idea. What if we divide both sides by 12,000?
Okay, so that would be a great first step, because what you're saying is it's times on this side, and we get this. Yeah, love it. But now I've still got the I locked away. Do you have the key to unlock the I, David? Paul knows what's going on here. And I see Shoshana has also said square rooted, not square root, 10th rooted. So if you want to get rid of the power of 10, what you do is you take the 10th root of both sides and you do that. Or another way of doing that, it's the same thing. The 10th root is the same as raising something to the power of a 10th. That would also do the job. So what are we getting for our answer here? So we should get some sort of number on the side equals 1 plus I, because you've got rid of that. And then you have to take the 1 to the other side. And then it'll be in decimal. If you want to write it as percentage, then you would have to do a little something. Okay, so my answer. So here's the bit that I was doing down there. So there's that bit. And if you move the 1 across, you basically get this long thing here. And then if you want to write it with a percentage sign, you must times it by 100. So you get 33.389. And then in this question, I think they said to 1 decimal place. So that's why it becomes 33.4. But those who got 33.39, I totally understand. I didn't give you a lot of time to read the question. But what I want to know is, are people feeling like they understand the way to get the I by itself? This is a different type of question to the ones we've done so far. And I want a thumbs up if you feel like you followed the logic. Thumbs down if you feel like I haven't really found growth rates or interest rates before. So just to give you an interpretation of what this means, it means that the population is growing by almost 1/3 every year, right? So, you know, like in the first year, if you start with 12,000, what's about 1/3 of 12,000? It's about 4,000. So in year 1, you went up to 16,000. Then in year 2, you would have grown about 1/3 of that again. So what's about 1/3 of 16? It's going to be about 5.5. So then I got to 21. And then that's how that cycle accelerates. Okay. So I see there is a mixture in the chat, eh? So we need to look at this type of question again after we'll do a similar type of question after the break. All right. I've been pushing you guys quite hard. And so what we need to do now is give our body some love. So we are going to stand up and stretch. And if you could pop your camera on, that would be fantastic. So I can see your lovely faces.
Come on, guys. We'd love to see your faces. Please put your camera on. Join us in this stretch. You've been working so hard. Give your mind a break.
There we go. Oh, don't let me have all the fun, guys. Come on.
Come on, guys, your body will thank you. Shout out to
Yeah, dude, I know
Lucifer.
you want to stretch, man. I know you do. Stretch it out. Stretch it out.
Come on, guys, you must have FOMO.
Yeah, come on. Oh, I'm not even joking. Like, this changes my life. There we go.
And just shake it out a bit.
There we go. Shake it out. Oh, goodness gracious. All that math stress just disappearing just like that. Where did it go? Okay.
Shout out to
Cool.
David and Madhu.
Yeah, they're putting some real effort in there. I like it.
Nice one, guys.
All right. Quick little brain break. What number goes up and doesn't come back down? Oh, you guys are too quick for me. Really? Ew.
Nailing this.
It is indeed your age. Yes, your age goes up and doesn't come back down, I'm afraid to tell you. So let me give you one other quick little puzzle. Can you solve this puzzle? No calculators.
No cheating.
Yeah, you have to use your brains. No calculators. What is the answer going to be for B? I see some answers coming in. The sneaky bit is this divided by, but I think a lot of you would have figured out that you can switch it to that. And then this is going to be that, which is that, which is that answer over there. Nicely done, Bukan and Lesejo. And oh, I see lots of people got that right. Okay, so clearly the moral of the story here is I need to up my game on the brain break because today was a little too easy.
I think you have a good balance though.
Yeah. Because the thing is, you can go too far in the other direction, and then the people are not happy.
Yes.
Okay, let's do a similar type of sort of back to front question, and then we'll move on to depreciation. So Mary borrowed a certain sum of money from a bank at a compound interest rate of that much. After 3 years, she owes 7,000. How much did she originally borrow? So see if you can. It's not the same, but it's the same idea. This idea that we don't just solve for A and P, or we solve for all the variables. See if you can work out what how much she started by borrowing. You can rewrite the formula, and it would probably be a good idea. So here we go. That is the formula on your formula sheet. So there's a compound interest rate, and there's been 3 years. She owes a certain amount. How much did she borrow when she started? So we're actually trying to find what P is, but we need to fill in what A is. And then we also need to fill in what I and N is. And that might take some thinking, because the I is quarterly, so I can't just write 15. I have to write divided by 4. And then for N, because it was 3 years, but it's now in quarters, this has to be 3 times 4. And so the final answer will require me to move this whole thing across to the other side. And so the answer should be 4,500.29. So yeah, to me, it looks like you guys are fairly comfortable at this type of stuff. The only thing that I picked up was that when you had to take the 10th root in the previous question, that still probably you need a bit more practice. But this type of stuff, you seem good to me. And so I'm going to move on to some depreciation questions. And yeah, then we'll go from there. Nicely done, Amina. Nicely done. So for those who have slight differences, so I see in the chat, there are a few students who have slight differences. Just give me a thumbs up that you understand where you went wrong. It could have been rounding and stuff like that. Okay, round it off. Okay. So what we do then is we use the answer key button just to help us with that. All right, perfect. Okay, so let's talk about depreciation. Now, the good news is it's really the same idea as interest, just kind of with a negative. And so I am going to, let's just do one question kind of along these lines. And then, because it's a very similar idea. So here is the situation that we are dealing with. The value of a piece of machinery depreciates from 10,000 to 12,000 in 4 years. What is the rate of depreciation, correct to 2 decimal places, if it's calculated on the straight line method or the reducing balance method? Now, the interest rate will be a yearly interest rate. So all I'm going to tell you is that the formula for straight line depreciation is that. For compound depreciation, it's that. I want you to try and figure out which value it is we're solving for and what the answer is for A and B. Because I feel like the stuff we practiced earlier is kind of the same skill, but just in a different, slightly different application. So off we go. And then if there are questions, please do raise your hand and I will assist where I can. I believe in you guys.
You've got this.
Yeah. I'm missing my students' faces. I wish I could see more of my students' faces. If only they would turn their cameras on. Wouldn't that be nice?
Maybe they're a little bit shy today.
No, they are, but it is, yeah, I understand. There we go. Thanks, guys, who turned their cameras on. I appreciate all of you, but I really appreciate. Oh, there we go. Oh, look at these lovely students. Okay. Okay, Lesejo, you raised your hand. Let's get your question.
So you don't give this answer in a negative. You can't possibly do that.
No, so because okay, so that's actually a good question. So because the negative is already in the formula, the I will come out as a positive, but you have to know that it is depreciation because you use the depreciation formula. Does that make sense? Whereas if you had used the plus, it would have come out as negative. So you raise a good point. If you used the plus formula, and some people do that, but then what you would have found is that it would have come out with a negative rate. Yeah, good question, good comment. And so for this first one, what we want to do is we just want to find what I is. And from the chat, I'll reveal answers in a moment, but the chat is saying to me that I is a 10% per annum depreciation, which sounds pretty good to me. I will find the answer in a moment, but let's try and get B as well. What's the answer for B? Yeah. Lesejo, what did you get? Or what is your question?
I have a question.
Okay.
How exactly are you supposed to find I? Because what I did was I took how I minus P from A, and then I minus 1 from that, and then I divided that by 4, and I did not get anywhere near 10.
Okay. So, okay, are you talking about the second one or the first one?
The first one, yes.
Okay, so let's just quickly look at, I would go 5,000 divided by 10,000 equals 1 minus 4i. So are you with me so far on that? Then this would be a half. And then I would probably bring the 4i to the other side. And then I would get 1 minus a half. So that's, yeah, I'm also getting something a little bit different. Let's just check my answers here, unless I've made a mistake. So 10% doesn't seem to be maybe I was being a little bit forgiving there. 12 and a half. Okay, so actually, this is really good. We've caught something which is like, so in terms of straight line depreciation, we've got that. 1 minus I times 4, we definitely get that. I'm going to bring this across, and what I'm going to say is this is actually a half is just 0.5. And so when I divide both sides by 4, I ends up being 0.125 or 12.5% per annum. Now that is for A. Yeah. Thank you, Lesejo. That was really good. So now what we want to do is we want to talk about how is this process different for the second one, reducing balance depreciation. For Gelo, you're perfectly right. It's 12.5. It's not 10. You're absolutely right. And this is the fantastic thing about having a community, right? So we do this together and we can always spot those little blind spots. So for A, the depreciation rate was 12.5% per annum. And that was the straight line depreciation. Now we're trying to work out what is the reducing balance depreciation. Now the formula will be different that we're using here. And so we'll have to use some little bit more spicy mathematics, but nothing too crazy, I promise.
Mr. Is?
Yeah.
Pokang is asking if you can please explain how you got A again.
Okay. So for A, I first had to say it lost value. So it went from 10,000. So I started with my 10 and I ended up with 5,000. And that's the losing of value, the depreciation. Then I subbed in these values. 4 was for the 4 years, which is over here. And so I got this. Then I times 4 can be written as 4i. So that's just mathematics. And then the 10,000 when brought across is, because it's multiplication on one side, it's division on the other. 5,000 over 10,000 is just a half. And so I've got this. Then I just moved that across and this across. And then basically I got 4i equals 0.5. And then if I divide both sides by 4, I get this. And that's the 0.125 in decimal language is 12.5% per annum, or 12.5.
Thanks, Mr. Ace.
Cool. So we've still got to look at the reducing balance one, which is B. And it's going to look quite similar, except I'm going to have an N, which is a 4. And so I'd like to ask the class, how do I unlock? We had this question earlier in the lesson. How do I unlock the I? Basically, what do I need to do to unlock this I? And it's being protected by this 4. I'm like literally making like a narrative here, but anyway, story time. So how do I unlock this 4? Yeah, you take the 4th root on both sides. Exactly, Loretta. So let's do, oh, actually, you know what? Before we do that, I'm jumping the gun. This 10,000 has to get moved across. And we get that. And then you can take the 4th root of both sides.
Mr. Ace, can you take a question from Leseho?
Yeah. Yeah, Leseho, what's your question?
I even forgot that I had my hand up. Now I was gonna say that you use the 4th root on both sides, but yeah.
Perfect. No worries. Perfect. And Rachel, from you?
Oh, so I wanted to ask, is it fine if you say, if you rather say to the power of 1/4 and the other side 1/4 as well? Oh, thank
If
you.
I'm honest, I prefer that because it's less writing. So like, you know, if I look at, let me just try and do the reverse thing here. So what Rachel is asking is, can you also just do this where you raise both sides to 1/4? Because mathematically that's equivalent. And yes, absolutely you can. It means the same thing. Yeah, Quebeca. What's your question? Yeah.
So I wanted to know, like, is it possible for you to just like make I the subject of the formula before substituting?
You absolutely can. So that's another way of doing it. So what you, there's so many methods. So let's just go back to the beginning and show what Quebec is asking. So if you want to get I by itself at the beginning, you would then do all the hard work at the beginning. So A divided by P is 1 minus then to the power of N. Now to undo that N, we have to take the nth root on both sides, which leaves us with 1 minus I. And then, okay, so, and then at that point, you would then, because it's a minus, okay, you would just bring it across and you would get 1 minus that. Yeah, you can absolutely do that and then just put the values in at the end. Cool. So what are we getting for our answer? Let's go and get that answer. Quickly bring it down. we should get 15.9. 15.991, something to that effect. Just check that for yourself and give me a thumbs up if you get the 15.9. And that's going to be our last question for the day, because I'll just do a little preview of the next lesson to finish off, but there's going to be no more questions today because we've done a lot. And some of you are writing exams tomorrow too, so that's all right. Okay. So if we look back at what we've covered in this lesson, we spoke about compound increase and simple interest increase. And then in the second half, we spoke about decrease or depreciation. And we can see that they're almost like two sides of the same coin. The mathematics that you use to solve for unknowns is pretty much the same. You just have to get used to this idea of the formulas and the maths you need to rearrange them. There are different choices of methods. As long as you're getting the same answer, not a problem what method you use. Okay. In the next lesson, we will talk about nominal and effective interest rates. So, I mean, that I started the lesson with stuff like that. And it's basically just that formula that I showed at the beginning of the lesson. And then the other thing we'll talk about is something called timeline questions, which is something like this, which I have prepared for the next lesson. Okay, so that is the focus going into